What if everything you've ever experienced, every star you've gazed at, every breath you've taken, exists only as lines of code in a cosmic computer? This isn't science fiction anymore. It's a serious scientific question that's reshaping how we understand reality itself. For thousands of years, humanity has wrestled with this fundamental puzzle. Ancient Greek philosopher Plato described prisoners chained in a cave, mistaking shadows on the wall for reality itself. Centuries later, René Descartes questioned everything around him, concluding that the only certainty was his ability to think. Today, as we stare into glowing screens and navigate virtual worlds, we're asking the same haunting question with new urgency. In 2003, Oxford philosopher Nick Bostrom introduced an argument that sent shockwaves through scientific communities. His simulation hypothesis suggests that if any advanced civilization develops the computational power to run detailed simulations of their ancestors, they would likely create millions or billions of them. The math is startling. If countless simulated beings exist for every real one, the statistical probability that you're among the real ones becomes vanishingly small. Elon Musk famously declared the odds we're living in base reality as 1 in billions. But this isn't just philosophical speculation anymore. Modern science offers tantalizing clues that reality might indeed be computational. Consider quantum mechanics, the strange rules governing the smallest particles in our universe. Quantum particles seem to exist in multiple states simultaneously until the moment they're observed. Then they suddenly snap into a single definite state. This behavior mirrors video game graphics that only render when a player looks at them, conserving computational resources. Physicist John Wheeler proposed that reality emerges from information, coining the phrase "it from bit." In his view, every particle, every force, every corner of the cosmos springs from binary choices, from bits of information. The universe, Wheeler suggested, might be asking itself yes or no questions at the most fundamental level. Some scientists have even proposed that space-time itself has a pixel-like structure. Just as your computer screen is made of discrete pixels, space might be composed of tiny, indivisible units called Planck lengths. Below this scale, approximately 10 to the power of minus 35 meters, the very concept of distance breaks down. It's as if reality has a resolution limit, like a cosmic display screen. The mathematical precision of our universe adds another layer of intrigue. From the Fibonacci spirals in sunflower seeds to the golden ratio appearing in galaxy formations, mathematical constants seem embedded everywhere. Pi governs circles from atomic orbitals to planetary orbits. The fine structure constant determines how light interacts with matter across the entire cosmos. These aren't random coincidences. They suggest an underlying mathematical framework, possibly even a cosmic code. Astronomers have discovered that galaxies arrange themselves in vast web-like structures spanning billions of light-years. These cosmic webs bear an uncanny resemblance to neural networks or computer circuits. Dark matter, which makes up 85% of all matter, remains invisible and mysterious, interacting with regular matter primarily through gravity. Some researchers wonder if dark matter represents the universe's background processes, like a cosmic operating system running behind the scenes. Recent discoveries in space exploration have revealed even stranger possibilities. Fast radio bursts, intense flashes of radio waves from deep space, arrive in patterns that some scientists describe as almost digital. Pulsars, spinning neutron stars, emit radio beams with clock-like precision that rival atomic timepieces. These cosmic lighthouses sweep across space with such regularity they were initially mistaken for alien transmissions. The search for extraterrestrial intelligence raises profound questions about simulation theory. If we discover alien civilizations, are they real or simulated? If we're simulated, would our simulated telescopes detect simulated aliens in a simulated cosmos? The questions multiply endlessly, like reflections in parallel mirrors. Quantum entanglement, Einstein's spooky action at a distance, demonstrates that particles can instantaneously affect each other across vast distances. This phenomenon violates our understanding of space and time, suggesting reality operates more like a connected network than separate physical objects. When quantum computers eventually achieve supremacy, they might simulate entire universes, complete with conscious beings questioning their own existence. Everyday experiences hint at glitches in our reality matrix. Déjà vu affects nearly everyone, creating the eerie sensation of reliving identical moments. Memory researchers have discovered how easily our recollections can be altered or fabricated entirely. Sometimes our brains fill in missing information, creating false memories that feel completely real. Are these natural quirks of consciousness or signs of imperfect simulation? The Mandela effect, where large groups remember historical events differently than recorded, has sparked intense debate. Some attribute it to parallel universes bleeding through. Others suggest it reveals flaws in our simulated reality's consistency checks. While most scientists favor psychological explanations, the phenomenon raises unsettling questions about the reliability of shared experience. Critics of simulation theory raise valid concerns. How could we ever prove we're simulated if the simulation is perfect? Any evidence we discover would itself be simulated. The hypothesis becomes unfalsifiable, more philosophy than science. Additionally, if there's a programmer or architect of this simulation, how would such an entity differ from traditional concepts of divinity? The computational requirements for simulating our observable universe boggle the mind. Every atom, every quantum interaction, every thought would demand enormous processing power. Even advanced civilizations might find such simulations prohibitively expensive. Perhaps they would only simulate the parts of reality that conscious beings actually observe, leaving the rest as compressed data. But here's the most profound question. Does it matter? If our love, pain, hopes, and dreams feel real to us, what difference does their substrate make? Whether we're made of carbon atoms or computer code, our experiences remain meaningful to us. A simulated sunset can still inspire wonder. Simulated relationships can still bring joy or heartbreak. Perhaps the simulation hypothesis reveals something deeper about human nature. We've always sought to understand our place in the cosmos, from ancient creation myths to modern cosmology. Whether we're questioning shadows on cave walls or lines of cosmic code, we remain fundamentally curious beings driven to explore, understand, and find meaning in existence. As we develop more sophisticated artificial intelligence and virtual reality, we're creating our own simulated beings. These digital entities might soon question their reality, just as we question ours. The cycle continues, consciousness contemplating consciousness across infinite recursive layers of existence. The greatest mystery isn't whether reality is real or simulated, but that conscious beings like us exist to ponder such questions at all. In a universe of countless stars and galaxies, thinking minds have emerged to contemplate their own existence. Whether that emergence happened in base reality or within a cosmic simulation, it remains one of the most extraordinary phenomena in the known universe.